Life and life.
All right, good afternoon, superstars. How are you doing? For some of you that attended English language class, I want to believe that you really learned a lot from Lucy. All right, so it's time for chemistry, and here you have Dr. Jan. All right, so first of all, I need to tell you that you're very, very lucky if you're on this program, as you're going to actually make sure you get to that particular score that you have in mind. You are going to exceed it. So the first thing I'm going to say is, how big is your dream in terms of your JAM score? For JAM 2026. So, like I've had students score 96 over 100, but I've not actually, as a teacher, broken that record of student getting 100, and I'm hoping to have you with you. So, if you are there seated, please I want you to reassess your dream, and I'm talking about your dream score. So make sure you possibly change it to 100 because it's possible. When you're having chemistry with Dr. Jan, every topic we treat, you must understand it. There is no other way about it. In my class, I don't usually have a spread of brilliant students, weak students, because everybody will get to understand every topic that is being taught. At the end of this class, you will see that that is actually true. All right. So today we'll be treating a particular topic that most students find very difficult. And the reason why I've chosen this, just to start with, is because majority of you want to possibly, some will do medicine, some paramedical courses. That aspect, it can limit your performance even when you get to university. So everything has to do with concept, and that is what we want to treat today. But before that, let's quickly talk about the JAMB as it is. Of course, everybody knows you're writing four subjects. All right, four subjects. Let's say we have English. Okay, we have English, math, physics, chemistry. So let's see. Let me write it on the screen so you can see that. Okay, let's say we have English. Okay, okay, so okay, you have English, you have math. Some people can write biology. You have chemistry, and you have physics. I just say this is like the four groups of students. Just wait. So English, math, or biology, chemistry, physics. English is like 60. The rest are 40 questions because we need to start from there. All right. If you add everything together, that's 120 plus 60. That makes 180. But you are going to be given just 2 hours, okay, to do this. So that means if you spend so much time on English or math or whatever, it's going to affect you on the other aspect of other subjects. But let's see that how much time do you have to spend on a particular question? If you divide 2 hours, that is like 120 minutes by 180 questions. You have something like 0.67 minutes, which is approximately 40 seconds, right? So that is what you have to make sure you get the right answer. So JAMP is all about speed, all right, about accuracy, and also about you being familiar with the questions that you have, all right, right in front of you. And at Tutoria, we have already designed our program to be like that, to give you that particular dose that will make you to realize your dream. So if you give you all the doses, just like a doctor will give medicine and drugs to patients, and you take everything the way we tell you to do that, I'm telling you, there is nothing stopping you from getting to 330, 340, and beyond. We have done it before. We understand the science behind learning, and we have formulated everything, and that is going to be great. So you're welcome on board, and I'll be taking you this topic, organic chemistry. All right. A lot of you out there will be like, organic chemistry again. There is no way I can understand this. Just take your pen because you're going to work with me We're not going to just be listening, all right, to Dr. John talking. You're going to be working with me, and we're going to really scroll through the entire course, which is organic chemistry, and you'll see how we're going to deal with it. All right. So in this class, we're going to recognize the homologous series as family of organic compounds. We're going to name and draw structures and define isomerisms. You name and draw structures of isomers. All right. So after that, we're going to pick some questions from JAMB, and then we'll see exactly how you are going to perform at the end of the day. And I can tell you, sit tight. You're going to enjoy the class, and at the same time, you're going to learn a lot of things in this class. So what is organic chemistry? Organic chemistry is simply chemistry of carbon-containing compounds. That means carbon is the star element there. If you look at what I've just said, carbon is at the center of the entire stuff. That means there is no organic compound that you see that does not contain this carbon, all right? So carbon is there as the star element. That means whenever you talk about organic chemistry or organic compound, carbon must be there. So you write it down that carbon is the star element when we talk about organic compounds. In other words, all organic compounds, they contain carbon. There are no exceptions to this. All right, so our star element is carbon. So why is the study of this organic chemistry very important at this stage, actually? I'm telling you, the whole essence of you, every part of your body, your blood, the build-up and everything is basically organic chemistry. And when you get to university, you continue with some of the aspect of chemistry that is called organic chemistry. But students find it very difficult because of some concepts that are very difficult to understand. And that is what we're going to do in this class. And I will be taking you through that. So please relax. If you've had a lot of raw days, maybe in your secondary school, it was very rough with organic chemistry because it's a very big section of chemistry that most students find very difficult. So just sit tight, calm down, and let's write this together, and we're going to see that. Okay, so before I go on, let's quickly look at the classification of organic compounds before we go forward. All right, in terms of organic compounds, we have an aspect of it that we call hydrocarbons, and that is what I'm limiting the class. I want to make it a sense of, a center of focus for you to know that, oh, let's treat hydrocarbons. I see how we are going to deal with this, okay? So basically, we're treating hydrocarbons, and now I can say, get ready, take your pen, and let's start working together. All right, what are hydrocarbons? Okay, hydrocarbons are compounds with only two elements in it, just like the name. We have hydrocarbons, so it contains just two elements, and those two elements are just hydrogen and carbon. You can see that I put only in red pen because you must understand that there are lots of other compounds that have carbon and hydrogen. Examples is one of them is ethanol. For example, ethanol has carbon, it has hydrogen, but it also has oxygen. So when you are giving the definition of hydrocarbons, even in multiple choice question, just like we have in JAMB, you must understand that hydrocarbons, they have two elements, and those two elements are simply carbon and hydrogen, and there is no other stuff in it. So what are the sources of those hydrocarbons? We see them in petroleum, natural gas, and coal. We're going to explore this very well later when we're breaking down our topics in different areas, because some of them falls on carbon and its compounds and some other topics. But we want to narrow it down to this classification. Now, look at this classification, and I want you to just sketch it in your notes as we're doing about it. So look at this. We have hydrocarbons, we have aliphatic hydrocarbons, we have aromatic hydrocarbons. We're not going into all these sections. We want to narrow it down to alkanes. So now, why am I picking alkanes specifically? This is where it gets more interesting. The reason why I'm picking alkane is because alkanes are the building blocks of all organic compounds. It's just like when you are your structure of your house there, you see that the unit is block, bricks, and all that. So Alkanes are the building blocks. This is where students have serious problem, because once you have serious problem with naming alkanes, you have serious challenges with how to deal with structure of alkanes. It will be very difficult for you to work on alkanes, alkynes, alkanols, carboxylic acid, esters, and all other ones that are within the scope of JAMB. So the problem is people don't know how to handle alkanes, and I want to make it super simple. Super simple. At the end of this class, you will see that you are now a pro when it comes to organic chemistry, and you love it more. So let's start and let's get it started. Okay, so that is nomenclature in our case. What is nomenclature? It simply means the system of naming. And we use what we call IUPAC, that is IUPAC. I means International Union of Pure and Applied Chemistry. That is the standard rule. Imagine I want to name arcane in my local language, and another person from the northern part of Nigeria or from China. So we'll be speaking in tongues. And so this body comes of different rules that we have to use to be able to name these hydrocarbons called alkanes. Don't forget, I said alkanes are the building blocks of organic compounds, and that's why you must know it. If you have problem, please just settle with me and let's trash this out now, because you're going to be working a lot of questions as we're doing. I'm going to drop in questions, then I'll be solving it. Then at the end of the class, we'll have some questions from JAMB together just to test your understanding. And I believe that everybody in this class, you will get all the questions correctly. So let's get to it. Nomenclature in alkanes. All right, so how do we name alkanes? All right, you simply name them the way they reveal themselves to you, just like your friends, okay? And you don't have to cram anything. So I just want to show you how to draw the structure, how to name them, and how to answer questions around alkanes. So that will make you to prepare for the rest of the compounds that are organic compounds like alkenes, alkynes. After that, you're going to talk about alkanols, alkanoic acid. You're going to talk about esters. You get to carbohydrates. So as you're building, if you don't understand this very well, you're going to have a problem with that. So let's quickly start. All right. So now, every family we have the first child, the second child, and like that. And that is actually how you're going to address this case. You may be wondering, what's the first child of Arcane? All right. So what's the second one? What's the third one? Just like the way you know your brother. You just one day, oh, my brother is Sunday, my brother is John. All right. So, and that is the way it is. So we have to first of all know the group of this family that we call homologous series. All right. Can you say it? Homologous series. Okay, that is the family of organic compound, just like you have family and you have spacings. Like me, my younger brother, the gap year between us is like 3 years. All right, maybe you, maybe it's 2. But in our case, they are well spaced, evenly spaced. All right, you're going to see the beauty in all these things. So, and I want you to please get your pen ready so that we'll quickly go into it now. All right, so the first thing we might want to do now is to let you see the first member of arcane homologous series, the first member. So what is the first member? What is it called? Okay, so let me just draw this. I want us to be doing it together, and that's why you're working. If you are in that class, in this class, and you are not doing that together, so you're not working with me, so you're not going to learn much. Okay, so let's represent that one with N. Okay, let's say that is N. Okay, the first member is this. The second member, okay, second member is that, then the third, the fourth, and the fifth. Okay, so what's the name of the first member? It is called methane. Okay, you can say it with me, methane. Okay, that is the first member of arcane homologous series. You just have to learn their name like this, just like the name of your brother. These ones are very easy this way. So the second member is ethane. Okay, so there are no rules guiding just the members. Just like you give birth, you give them their name. That is just the way it is for this group. So let me name this as arcane. Please, I want you to do this in your notes with me so that it's very easy. Okay, don't mind my line over there. So methane, ethane. Okay, you can see my handwriting is the best. What do you think? So methane is there, ethane is there. And let's look at the third one. Okay, the third one is propane. Okay, propane. Okay, so that is it. If you can write better than me, test it and compare with what I've written, and you give me feedback later, maybe in one of my videos. And let's see whether your handwriting is as good as mine. All right, number 4 is butane. Okay, I'm going to stop at the fifth one. So, but I want you to see the pattern that where people have problems. So basically, I'm saying that we have the first 5 members of arcane homologous series. We have in front of you the first 5 members of arcane homologous series. So the first one is methane, the second one is ethane, the third one is propane, and the fourth one is butane. All right. So what do I want to do with it? You are going to see how they look like. What is their structure? Are they tall? Are they straight, in figure and all that? So you're just going to pick it up now. So what is the formula for methane? That is where the formula comes from. We have alkane homologous series. That is CnH2n plus 2. That is the formula that we use to identify all alkanes. That is what we call their general formula. CnH2n plus 2. Please write it. CnH2n plus 2. Now we're going to work it together one after the other, and you will see how easy for you to work this. Now, methane has one carbon atom. That is N. That is what N represents. N represents the number of carbon atoms. Okay, so N represents the number of carbon atoms. So you don't have to get worried about that. So now, if you have methane and N is 1, so I want to work something. So Cn, can you see? I put C1, then let's do it together. H2 into 1. So it's like CnH2n plus 2. So when you look at, you will see that, look at this, you will see that we get C1H4. Okay, so that is the formula for methane. So the chemical formula for methane is simply CH4. So some people cram this and they'll be wondering, how did you get CH4? Some people will say CH3 something, something. You don't have to. In fact, if you cram, you're going to stress your brain because you're abusing that complexity of your brain. The best way is to find how, and that will make you shouldn't be writing chemistry questions and you'll be sweating. All right, even if I put the AC on to the maximum, some people will still be sweating while they're writing chemistry questions. And I'm telling you, that is the best subject you can. In fact, chemistry is the easiest subject. All right, as you're going to see with me. So that is CH4. So let's try to find out the formula for ethane, which is the second member. Some people are already like, oh, if this is it, it's very simple. So Cn, so I'll put 2 here because ethane has 2 carbon atoms in it. So C2, all right, how many H would it have? Now H2, 2 plus 2. All right, what I'm saying is we have a general formula for arcane homologous series. That means their family have a rule that guides them, which the formula is what gives us the structure of arcane. So you can see now, so what will be the formula for ethane? So let's work it out. I believe that everybody, 100% of my students watching this should be able to get this. So that is C2, right? H, 2 times 2, that is 4 plus 2, making it C2H6. So that is just the formula for ethane. So when we say what's the formula for ethane, that is C2H6. And it's as simple as that. So let's go for propane. What do you think propane will look like? I'll quickly do that. Then I will give you just 1 minute or within 30 seconds to drop the next two, which is number 4 and number 5. Let's do propane and let's see that. Propane is C3, okay, H2 into 3 plus 2. All right. If you're just joining away, we are working out how to get the formula of arcane homologous series in a very simple way. And we have talked about the fact that their general formula is CnH2n plus 2. Okay, so we are now trying to put the number of carbon atoms, which is that first column. Okay, the first column here, that is the number of carbon atoms that are present in this alkanes. So that makes it C3, 2 times 3 is 6 plus 2. That makes it C3H8. Okay, so of course, try this too and see whether you'll be able to get it. I'll just write the formula. Okay, write the chemical formula for butane and pentane using the formula CnH2n plus 2. I think everybody should be able to do that. If N represents the number of carbon atoms, which is the 4 columns. So butane has 4 carbon atoms. So how many hydrogen will it have? So I will just write it. I'm not working now. C4. If you get it, you can let me know. 2 times 4 plus 2, that is C4H10. Then the next one is C5H12. All right. So that is the first 5 members of alkane homologous series. The question somebody might want to ask me there will like, okay, so are these just all the children in alkane family? The answer is no. But where does our syllabus stop? Okay, your syllabus, which is JAMB that we're treating, would want you to know at least the first 10 members. If they are going beyond that, there are other children beyond 10, they would mention it by themselves so that you know that this is the compound, but you must know the first 10 members. What did I say? You must know the first 10 children of alkane family. Please don't forget that. Whatever I tell you, just know that that is the truth and just believe that. Okay, please write it that the general formula of alkane homologous series is CnH2n plus 2, while the numbers of children that you should know, that you must know, is at least 10 carbon atoms. Okay, so that means the first 10 members of alkane homologous series. That's what we're talking about. Okay, so let's see how we are going to continue with that. What's the name of alkane with 6 carbon atoms, 7, 8, 9, 10? I think it's better for me to just write their names and let you decide on the formula. Okay, so I will write the names of these next 5 so that you would determine the next one. All right, we'll still pick our N. Now it's going to be 6, 7, 8, 9, 10. Now I'm not going to work out the formula again. You'll be the one, but I just want to write the name. So what's the name of a polygon with 6 sides? You say hexagon. So this one can help you. You can now say hexane. Okay, name of polygons with 6 sides is hexagon. So it will help you. What's the name of a polygon with 7 sides? Okay, is what? Heptagon. So this is heptane. You can see that the correlation there. So what about this one? It will be what? Say it again. Okay, it will be octane. Okay, now nonane and decane. We will not get to cocaine. Cocaine is another group of organic compound. Okay, some people are saying, oh, this is the family of cocaine. Cocaine is another group of organic compound entirely, so which has oxygen in it and all that. These are alkane, which are just hydrocarbons. Now, hexane, heptane, octane, nonane, and decane. Remember, everything is showing ANE there. Okay, I'll just write the formula for C10. C10, H22. That is what is going to be the formula of this, because we are saying C10, H2 times 10 plus 2. That is it. You can see how easy for you to write the formula of alkanes now. And I want to believe 100% of my students right on this call, in this class, will know that. It's very simple. C10, H22 for decane. All right, 11 will be on decane, do decane, try decane, and all that. But it's not your business. If JAMB wants to ask question about that, they can tell you. Okay, let me just give you an example. If the question says this is an alkane, CXH18 is an alkane. Okay, all right, so they say what will be the value of X? Okay, since you just compare with this formula, some people will say, oh, I can really just suggest, since it's 2 times 2 plus 2, what will give me 18? You're right. So CnH2n plus 2. So you just see that you equate 18 to 2nH2n plus 2. So 2n plus 2 equals 18. So you now get 2n equals 18 minus 2, that is 16. So divide both sides by 2, you get 8. So that shows that our X is 8, and that is octane. All right, so they can ask you question of anything beyond 11 like that, just to show you, oh, this is an alkane. And I believe this one is clear. Everybody should be able to do this. Now, the question is, all the formulas that we wrote, what is the name given to those formula? I want you to listen. That's another concept that is very, very important. I can spend a lot of time with students on arcanes, because it makes my work very easy when I'm dealing with the higher ones. Like I've told you, after arcanes, you're going to use arcane to build arcanes. You're going to use arcane to build arcines. You're going to use arcane to build arcanos and all that. So I can tell you that it's going to make my work very easy once you understand arcanes. We'll just be moving so fast and you'll just be getting everything. There are some of my students will be saying that, are you telling me is this simple? That is it, is that simple? All right, it's because you've not seen the right secret. That's why possibly you think majority of these things that we're teaching you, they are very difficult. They are actually very simple, right? It's as simple as you knowing how to share cookies among your friends. It's that simple. So what these names that we talked about, what are they called? All right. The formula we are talking about, let me just show you what I mean. Okay, this formula that we wrote for methane, I said, let me pick, right, okay. So we wrote methane, okay, methane, all right. The formula, methane has one carbon atom, so we say the formula is CH4. Then if you compare with what you have, I believe everybody can do that now. Methane has C2H6, all right, propane. I want to bring something out from there, C3H8, okay. Now look at this. Between these two, what can you see the difference? You see that we add one carbon, okay, one carbon and two hydrogen. That is CH2. Within these two also, we also add one carbon, CH2. That shows that they follow regular repeating pattern and the spacing between them is CH2 group. A lot of questions have come out in JAMB asking about the spacing between the consecutive arcane homologous series. So you can see that if I want to write the next one, which is butane, instead of me to work out the formula, I'll just add CH2 to this. Remember C4H8, H what? You're going to be H10. All right, if you work it out, you're going to see that's going to be the next formula. The next formula, if I add CH2 to this, it's going to be C5H12. When you look at the table I told you to write for pentane, it's C5H12. What does that mean? It means that you can actually work very fast when you understand the concept in its entirety. Just look at the question, because JAMB is about most people that really they are good, that can score 98 in chemistry, 96 in physics. Some of them may be slow, all right? So you have to work on your speed. It's about accuracy, speed, and you being familiar with the question. And I want to stress it. We have taken all those things into consideration. Most of our questions are like that. They test all the things that we have on our platform. You will be able to, help yourself with those questions. And after you have practiced again and again and again, you will see that when you're writing JAM, you will be smiling. Somebody looking at your face that didn't choose tutorial will be like, what is wrong with this guy? When you come out of the exam or they may want to ask a question, why are you smiling? It's just because you have seen those questions before or they look familiar. Because once you understand the concept, it's very simple. All right. So what I'm trying to say is that between one and the second one, they have equal spacing. It's just like in a family, the first child is 24, the next one is, let's say 22, the next one is 20. So you can see 2 years equal spacing. Arcane, they have 14 units. Okay, so some people will be like, you just said CH2 now, and how does it amount to 14 units? Let's work it out. CH2 units, that's the gap. All right, C, like spell 12, that is relative atomic mass. For hydrogen is 1, okay, making 14 units, okay? So that means arcane homologous series, they are separated by CH2 unit or 14 units, all right? So that is how it is. 14 is from adding their, how heavy they are, and you add them together. So that is how they are. So this formula is what we call molecular formula, all right? This formula that we just derived for the first 10 members of arcane homologous series is called molecular formula. What is a molecular formula? Pick up a pen and write as I say it. Molecular formula is the formula that shows the actual number of atoms in a molecule. Actual means that how many carbon and how many hydrogen are there. Okay, so that is molecular formula. Okay, okay, it's very simple. Just like we have ethane. Ethane is the second member. So I will write C2 is going to be H what 2 times 2 plus 2. That is C2H6. So that shows that this is the molecular formula of ethane. Okay, so if it's not molecular formula, what other formula is possible that JAMB can test us about is what we call empirical formula. Okay, empirical. Okay, so molecular formula shows the actual number of atoms present in a molecule of a compound. So how many carbon has ethane? We say 2 carbon atoms. How many hydrogen has ethane? We say 6 hydrogen atoms. So that is what we call molecular formula. It shows the actual. Please write it. Don't just look at me. Write it. Molecular formula shows the actual number of atoms in a molecule of a compound. Now, what is empirical formula? Empirical formula shows, can somebody guess? All right. So I pause for 2 seconds. What will empirical formula do? Just the simplest O number ratio. Okay, simplest is a formula that shows the simplest. You must understand that O number ratio. Okay, so how do I get that? Just C2H6. Can 2 go in 6? So look at that. Yes, of course. So that means the improved formula for ethane will be CH3 because it shows the simplest O number ratio, which is C1 to 3. So that means for every 1 carbon in ethane, you're going to have 3 hydrogen atoms. So you just cut it like a working fraction. Look at what I did. Okay. Now somebody may want to ask, okay, let's do methane. Methane, which is the first one. What's the formula for methane? I'm asking you now. You should be able to know. What's the formula for methane? Methane is the first member. So it's CH4. This is what we call molecular formula. Okay. All right, molecular formula of methane. All right. So then you see that if I want to write the empirical formula for this, I can't cut it down in any way because I have one C1H4. So the empirical formula is also CH4. That means empirical formula and molecular formula can be the same. Don't you see that? So that is very beautiful. That can help you also in multiple choice questions. Empirical formula and molecular formula can be the same. So I give you butane. What is the molecular formula and empirical formula for butane? I want you to quickly do that now. Let's look at it. So now that you have seen how these are working out, you can see that you are almost done in learning the entire organic chemistry once you understand alkanes. Okay, because the next part remaining is actually how to name and draw their structure, which I believe that you really want to learn that. All right, so just sign up so at least we can have more time together. Okay, don't just let this go and you think, oh, let me just try to solve it on my own. So let's see butane. Butane is I said butane C4. Okay, C4H10. Okay, butane is C4H10. Okay, because that's 4 carbon atom. This is the molecular formula, which you can see as even MF molecular formula. All right, because butane has actual 4 carbon atoms and 10. So what is going to be the empirical formula for butane? All right. So empirical formula will look like who? Can I cut this into simplest ratio? 4. Can 4 go in 10? No, because it will give you decimals. Okay, we said the simplest O number ratio. All right, so let's see 2, whether 2 can go in 4. Yeah, beautiful. And this one 5. That shows that for every 2 carbon atoms, there are 5 hydrogen atoms in butane. So that shows that this is the empirical formula of butane. Another thing I want you to learn from this is just like you know that molecular formula and empirical formula may be different and they may be the same in organic compound because the ratio can also be the actual, just like we see in methane. I think that is very good. All right, we have some few minutes and I have to just introduce in just next 3 minutes, just to look for when alkane introduces a particular member of alkane introduces himself or herself to me, how will I name such fellow. So let's see how you can do that. And it's very important that you learn that. So before we go, so that at least you go with something and you see that, oh, this is actually very beautiful. I'm enjoying the class myself, and I hope you are actually doing the same thing. So we are moving to real nomenclature, and it's very, very simple. Okay, it's very, very simple. So don't let us waste time on this. So let's say we want to name a king proper. We draw the structure. The jam draws the structure for us. All right, unfortunately, we'll not get to most of the question, but what is important is you understand the concept and you go into the past question and start devouring those ones. Okay, so if I have this, look at the structure. Now, this particular compound has C4. In writing the structure of organic compound, I will say that again in case that caught you unaware. So, in writing the structure of organic compound, you must maintain the tetravalency of carbon. What does that mean? It just means that when you draw the structure up, just like what you're saying, there must be 4 bonds around carbon atoms. If you have 3 bonds, that shows that you're stingy. How come? Carbon will be angry with you. And if you add extra, carbon does not want unnecessary favor. Just give me what I need. Carbon needs 4 bonds around it. Okay. I think you have some friends like that. No, 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 no. I'm okay with this. Okay. So please don't deny carbon of all the 4 bonds and don't give extra. Okay. You may be stingy and may be too generous. And carbon does not want that. Carbon just wants exactly the number of bonds around it. That's what we call tetravalency. Tetra means 4. That means the bond around it must be 4. Remember, this is just 2 examples that we're going to do here. And I believe that you also want to join and see other wonders that we have. So now, look at the bond. 1, 2, 3. The fourth one is here. Then 1, 2. Look at this. The second carbon. Okay, maybe you want me to name it with red. Let me just pick that red and put the numbering on this carbon. Look at that. Okay, so we have 4 carbon atoms there. Okay, we have 4 carbon atoms there. So I have the first carbon, which is C1, already has 4 bonds around it. That is what we have there. The second carbon too already has 4 bonds. Those are the lines. You don't have to count it as long as you maintain that. So that is also how you can gain speed when you are solving a question. So let's see C4, how many H? 4 up, 4 down, row, then 2, H10. This is in steps with the formula of alkane CnH2 plus 2. So you just call this compound butane because they wrote it for you. Okay, butane. We have just one more example and we'll close. But I believe that you would want to see what happens to other members as we're actually treating this. So let's see number 2. That is butane. Okay. Now, I may have this and I have, okay, let me clean this. Let me clean this. Okay. So we may have that just 3 carbon atoms. Okay, just 3 carbon atoms. Sorry. Okay, we may have this. Okay, so we have these 3 carbon atoms. That's what I want to do now. So let's see how we are going to name this one, and that will be the last compound that we're talking about. So now I put H here. I put H. Now you know that every bond must be 4. Okay, so let me now put CH3 here. Okay, so it's supposed to be hydrogen. This guy is supposed to be hydrogen, but it's another thing. So that is just the problem. Most people will like, oh, how will I know what to spot out? That is what we call a substituent, just like a branch. So it's supposed to be C3. So hydrogen is supposed to be there, but it's not. So what is the name of CH3? it is called methyl. Okay. In subsequent classes, I'm going to explore how to identify these substituents and also how you can name other substituents apart from this. So that means methyl group is attached to carbon number 1, 2, 3. Can you see that? So this methyl group is attached to carbon number 2. A methyl group is CH3, is attached to carbon number 2. But what is the name of an alkane with 3 carbon atoms? That is propane. Okay, so you just write propane. The methyl group is attached to carbon number 2. You now say 2 has methyl in it. Okay, remember there is a dash line between the number and the alphabet. So 2-methyl propane, because methyl group is attached to carbon number 2. All right, I want to believe that you have been able to learn some concepts. This is just a tip of the iceberg for you to know. You have a lot of concept to learn, and I want to believe that this is very easy for you, and you're able to learn a lot of things. So in some other classes, I believe that you will join me and you want to know more. So please don't waste time. Once it's time for any of your subjects, because we want to actually break records. Just like we are telling you to get everything, we want to break. I want to get a student, and I want it to be you that will have 100 over 100. Okay, make sure you attend all my classes, and I want to congratulate you ahead of time that once you do what we're telling you to do, you're going to have a very beautiful class. All right. So if you have any question, you can always go to my social media channels, YouTube channel, Facebook, um, Instagram. Drop the comment. If you have a problem about a particular concept, just tell me, Dr. Jan, I would like you to explain this. I will make a video for you because we were just ready for you, wanted to learn. So thank you very much, and it's been a very wonderful time. All right, thank you. Bye for now.